the brief biodata of today's resource person, Dr. V. Karthikeyan.
Good morning to one and all. Dr. V. Karthikeyan Garu, working as an assistant professor in the Department of Electrical Engineering, National Institute of Technology, Calicut. He has completed BE and ME degree from Anna University, Chennai and Coimbatore respectively. He has completed PhD from NIT Allahabad, Uttar Pradesh in the year of 2016. His current research focuses on integration of renewable energy systems in the smart grid, energy storage systems, and modern power converters for advanced electric drives for electric vehicles, and also recent trends in IoT based applications. He has 15 years of academic and research experience. He has published 3 book chapters in Springer International. He has published more than 43 SCI recent papers from various journals like IEEE Transaction on Industrial Electronics, Industrial Informatics, Circuits and Systems 2, IET Power Electronics, and few more Elsevier journals. He is serving as a regular reviewer in various IEEE transactions and Elsevier journals. He has presented the papers in 35 reputed IEEE international conferences like IECON, UPCON, PEDS, NPSC, and RACE, and also he got 5 times Best Paper Award from Taylor University, Malaysia. Taylor University, Malaysia, and NIT Tiruchi, and IIT Madras, and other conferences. He is also having 1 patent in the year 2020. Recently, he has received the Best Faculty Award in Tamil Nadu region from Nehru Group of Institutions, and also received the Best Young Researcher Award from AINAE, India. He has received the projects 5 lakhs from NIT Calicut to build electric tricycle at NITC campus, and 24 lakhs from TEQIP 3 collaborative project scheme under NPIU, and also 36 lakhs from CSIR to build a solar PV based smart irrigation system. Also, recently he has received 15 lakhs fund from BIRAC scheme, Department of Biotechnology. So academics and R&D outcomes. So one startup company and running successfully since last 3 years. 2 products developed and commercialized in market. The guided 2 PhD students and 5 students ongoing. The guided 30 plus MTech students and 5 ongoing. So I would like to request Dr. V. Karthikeyan Garu to hand over the mic and to deliver the lecture. Thank you.
No? Audio is coming? Can you check whether those people are listening? Audio is sufficient? Can you check, sir? No, you are telling online. Yeah. So can you share the screen, sir? So very good morning. Yeah. So can you come a bit forward? Yeah, you can come and sit here. You also, few people. Come front actually. Yeah. Are you not? Yeah, it's fine. Okay, thank you, sir. Don't worry, I'm not going to ask any questions. Just an interactive session only. Please come. Okay, where to where is margin? I should not move. Recording margin. Only from here. Yeah, continue. It's fine. No. Yes. No issue. Yeah. Can you slide? Around 72 slides are there, right? Other than the references, not more than 65. So 60 to 63 only. There are many things I'm going to skip actually, right? So more or less I'm going to spend around 1 or 2 minutes only each slide, right? Certain slide hold in 2 to 5 minutes. Depends on the strength, right? And totally 3 hours now I'm going to interact, out of which 1.5 hours I will take till 11:20, then I will 10 minutes break, then again 11:30 to 12:45, then last 15 minutes we can have an interaction. Whatever the queries you like to ask, definitely I am ready to answer, right? So I hope everybody is from BTech, right? May I know who are all other than the BTech? Mostly BTech only, na? So may I know which year? Is a final year or third year? Third year students. Any final years are here? No. Okay. So very important thing is first we need to understand the listener capability. Otherwise, whatever I am teaching this become waste. Okay. So this particular session, I would like to advancement in EV and its charging infrastructure that I would like to discuss. So these are the overview of the session in this particular presentation. Important role of motor drives and the energy loss analysis in EV, and the research challenges in charging methodologies and infrastructure, and also the various digital controller utilized in a hardware design, and the important tips while performing the experimental work. So before I start this one, I think most of the people are aware about what is called electrical vehicle and what are the structure of the electric vehicle. So as you know very well, in a normal engine operated vehicle, more than 10,000 spare parts are moving actually. So because of that, regular maintenance are required, and minimum per kilometer we have to spend at least, including maintenance charge, 4 to 5 rupees. Less than 4 rupees you are not able to run any engine vehicle, either 4-wheeler car or even the 5-seater or 7-seater, whatever it is. It will be above that value. Minimum, including maintenance and service, everything, approximately 5 rupees per kilometer. For example, you like to travel 200 kilometer, minimum 1,000 rupees you have to apply either petrol or diesel, whatever it is, right? But whereas an electric vehicle, it is not like that. Scenario just opposite. 10 paisa is the operating cost per kilometer, which means if you want to travel 200 kilometers, same 1,000 rupees, but whereas here 40 to 50 rupees is enough. Maximum case. So 10 paisa minimum it is starting. At present scenario, market available 40 paisa maximum cost. You don't need to spend beyond that. Let it be 50 paisa including operation and maintenance, everything. Which means compare with the engine based vehicle, 10 times cost reduction. 2,000 rupees you were applying the petrol or diesel, just 200 rupees is enough to travel the same distance with the maintenance I'm talking. First advantage. Second advantage, as I told you, 10,000 mechanical parts, small portions are moving. But whereas in electric vehicle, it's not like that. Less than 50 spare parts only moving. In which there are 3 major. But whereas in case of engine, if you are looking, there are n number of parts are available. Everything regular maintenance are required. And life of the engine based vehicle, government is announcing only 20 years. After 20 years, it has to go scrap, but people are driving even 25 years vehicles also. After 7 or 8 years, the performance totally get degraded. But whereas In electric vehicle, it's not like that. Only three are the major portions. What are the three are the major portions? May you know? Electric vehicle, battery, very good, one of the first thing. Second thing, motor with the drives together, right? Third, BMS and all extra facility. Three things only. One is motor, another one is the battery and the controller, the entire controller, right? These three things only available. If you are taking these three things, nothing would be there. Like an empty box only, right? For example, after 10 years, my performance became worst. Nothing to bother. Just to replace the motor. Motor cost around not more than 20,000 rupees. Just you can replace another 20 years you can run the vehicle. So that electric vehicle is everlasting. Same vehicle that you can ride, only you can replace the motor and respective controller. That's it. But whereas an engine vehicle, it's not like that. Everything mechanical. Over a period, you have to either crash or you have to go to a scrap and the other vehicle has to purchase. So that is why most of the country, they are moving towards the electric vehicle. Okay, so this is not a new. From 18th century, people are talking about it. Especially last 1 decade, people are talking about only electric vehicle. But you are unable to see anywhere in the road. Even our government vision also what? 2030, 30% of the vehicle has to be replaced with electric vehicle. What? Traditional vehicle. Traditional vehicle means engine vehicle. 30% only our government vision. Why? Why all of a sudden, why not able to replace the entire engine vehicle into electric vehicle? Which means some problems are there, right? Some research challenges are there. What are the research challenges? What are the problem? As a young community student like you, what you need to contribute to the nation, especially most of the companies, they are going to invest towards electric vehicle next 2 to 3 years. Huge investment is going to hit in the market, especially Indian market. They want to replace the entire thing, but still some challenges are there. Gradually they are going to increase. So at present scenario, what are the challenges are there? How to overcome it? That is what we are going to see. I don't want to go much detail about that one, but I would like to explain little bit research point of view also, so that you will get an interest as you are doing a third year. You may not much aware about that one, but of course it's a recording session. Whoever looking this video, so definitely they will get a better idea to go for the further research activity. So I will satisfy you people also who are all watching in online also, right? Fine. So let's begin with the first one. The requirement of EV. As there are two things. One is a customer point of view. I am a customer. What I am going to look electric vehicle. And you are a manufacturing industry, in R&D engineer. What you are going to do something to satisfy me. First point, as a customer, what I look, the electric vehicle should be being safe and no environmental gas. No doubt in that. There is no pollution actually like an engine vehicle. First point, it's fine. But second point, being autonomous, but may not be required at present scenario, country like India, huge population. Many, automated Uber and all came, like how we are having Ola and Uber, no? Like that in other nations and all, full driveless, this vehicle and all came, so that we can book the app actually accordingly, the vehicle will come and we can ride and we can do the payment, driverless. So that is available. But that much facilities are not required at present scenario India. But the third is a very, very important, very good mileage. Whatever it is, electric vehicle should give very good mileage. Mileage at least 45 km per hour average. Once full set of charge, at least 200 km or 150 km my vehicle has to ride. Then only I will come towards the electric vehicle. Otherwise, only 40 km, only full charge. After 41 km, again you have to charge. It will take around 11 hours, 12 hours. How can I come forward? I don't want this one. Petrol pump, if I am going hardly 2 minutes, 3 minutes only I am spending for petrol diesel, right? But in electric vehicle to charge, 11 hours, 12 hours. I don't want to spend that much time. At least one full set of charge, 200 km my vehicle has to ride. Then I will come forward. So which means very good mileage. 45 km average speed, it has to bring, right? And second thing, quick charging time. I don't want to wait 12 hours and 14 hours. Within a short span of time, I need to charge. If you are able to provide one manufacturing industry, then I will come definitely. Right? These are the requirement from the customer. Right? The other thing, acceleration. This is one of the most important point. Acceleration means most of them are aware about, right? Initially, when you are racing, the vehicle has to pick up the speed. But whereas in ordinary EV to scooter, what is called e-scooter and all, whatever available in the market, It's not that much pickup actually. Only old age people only used to ride. Youngster never come. Like youngster, why people are going 100, 150 cc and 200 cc? Now bullet train and sorry, what is that? Royal Enfield came 500 cc capacity. Why people are moving towards that? Very good acceleration. Moment you are rising, it has to pick up. But that kind of provision you have to create where? In electric vehicle. It's not like that simply in terms of 1 HP motor replacing with a 5 HP motor. That is not a solution. Same HP motor, we have to do some kind of control technique so that very good acceleration has to come. What is the control technique? What we have to do research point of view, that we will discuss. But you need to understand as a customer what I am expecting from you, at least 0 to 100 km per hour within 15 seconds it has to rise. That is called rate of acceleration. That should be very high. The other thing, very important point is running time, dynamic response. If I like to overtake any vehicle, you should have a capability. If I am unable to overtake only beside lorry, if I keeps on moving, I don't want to come towards the electric vehicle. I should have a capability to overtake any vehicle at any running speed with a heavy load capacity. Right? That is a very important. The other thing is by considering all these things, okay. So these are the requirements from a customer side. Okay. Now it's an engineer point of view. What you need to concentrate to satisfy the customer. First point, as I told you, high torque at low speed. At present scenario, what is happening in engine-based vehicle, two-wheeler or four-wheeler? You know, gear vehicle, first gear, second gear, third gear. What about the torque profile at first gear? Torque will be very high until first gear. But what about my speed? It will be very low. But whereas a fourth gear, fifth gear, speed will be very good, but you won't get that much torque. How? Because of gear mechanism we are doing, but same acceleration. We are converting. But whereas in electric vehicle, there is no gear. There is no gear actually. Like mechanically, that nothing is available. Only motor, this one. Now I am pressing the acceleration. At time of starting, your torque should be very high, speed at very low. So that kind of profile you have to create in a controller, such a way by adjusting the PWM, torque will be high, speed will be lower. Like that your motor has to operate. That kind of drive capability should be there. That is what? High torque at low speed. Second thing is high torque power ratio. So instead of to increase my torque, it's not like simply 1 HP motor to 2 HP motor and 5 HP motor. That is not a solution. Same HP motor, you have to increase the torque. You know very well, power formula omega T, right? Omega is a 2 pi n by 60 and the T is there. So either speed you can increase or torque you can take, any one you can do. So what I can do at lower speed, increase the torque. Power remains same only. So that kind of provision you can achieve where? In case of motor. So that is what? High torque, lower power. With the same 1 HP motor, you have to increase the torque. How to increase the torque? That is the control technique. Right? The other thing is constant power at wide speed range. Starting also, when I am rising accelerator, it's not like more current you are consuming from the battery. Then full battery get drained out, the mileage will be very less. I don't want that one. Same power only at time of starting also same power, at a maximum speed also same power. So power consumption should be uniform at wide range. So then only very less power I will take from the battery. What about my mileage? Long distance I can travel. So that kind of provision also you have to provide. That is what? Constant power in a wide speed range. The other thing is efficient. So in order to provide all these things, you should not put a more component so that efficiency become very, very less. More losses. That kind of things also I don't want. With a less number of losses, less number of devices, technique only you have to use so that efficiency should be very high. This is very important. Other one is a dynamic response, as I told you, running torque, right? And accurate electronic controllability. This is another matter for electric vehicle. In case of engine vehicle, everything mechanical, smoothly we can operate. But whereas in an electrical vehicle, how finally I am adjusting the speed, finally I have to increase or decrease the voltage. Am I right? So increase or decrease the voltage, PWM is the one of the best method. Most of them are here what is called PWM, right? Pulse width modulation. The 0 to 1 is the maximum. So when I am adjusting the duty cycle, what will happen? My output voltage get increase or decrease. When I am raising the acceleration, what is happening? The width of the PWM get increases. When I am leaving the acceleration, width of the PWM get decreases. So PWM width get increase or decrease. Accordingly, my voltage increases, decreases. So what I am supposed to do in order to achieve this one, accurate electronic control would mean when I am adjusting the acceleration, minute variation only has to happen. Only large variations are happening. Either motor will run 200 RPM or 600 RPM. In between I cannot control. So accuracy will not be there. I want to park in between this gap. So it is not possible because your speed will be either 200 or 600. In between minute range, if you are not able to adjust, you cannot ride proper way. So that is what accurate electronic capability, controllability, that should be there in the drives. Right? The other thing, robustness and reliability. This is another matter. Robustness, reliability mean the connections, everything electrical connection. In case of mechanical, everything with a screw, bolt, everything properly mounted, right? But whereas in electrical, everything wiring, right? Proper soldering with the PCB. Now anywhere connection get disconnected, then everybody is not an electrical engineer, easily they can resolve, right? Normal people also, they don't know what it is inside. Then very difficult to troubleshoot. So whatever the speed breaker moment comes, small vibration will happen. For that suddenly some connection gone, you just think about that practical situation. When I am driving, suddenly motor gets stops. I don't know what, without knowing the reason. It's a very difficult actually, right? So you should have a very good robustness and whatever the reliability of the entire drive should be very high. Then only you can attract the customer, right? By making all these things, you are not supposed to increase the cost. Cost should be very less. The other thing is low EMI. Low EMI means electromagnetic interference. The electromagnetic interference, most of the people are aware, right? When you are going mobile near to your telephone communication, TV and all, you know you will get some kind of, that is called electromagnetic interference. Whatever the mobile frequency wave, that will make a disturbance in the other wave. So which means one high frequency wave disturbance in the high frequency wave. That is a major problem. So when everywhere electric vehicle, the drive units are there. Drive units mean combination of IGBT, MOSFET, that and all, you know, you studied, right? That only inside would be available. Now everybody started using mobile phone inside the electric vehicle. Data, high frequency, that you know, data uploading and downloading, internet. So by the time, this way, when it is disturbing the MOSFET getting signal. So when I am raising the acceleration, what I told you, PWM will be increases or decreases. Now when I am rising, other than PWM increases because of my control, because of my mobile, this signal will be influence the PWM, so extra width will be coming. The extra width, how it came? Because of external disturbance. So I want to control certain speed, but due to your EMI, vehicle is running in other speed. So you loss of control. So that is why EMI arrestor has to be provided every PCB, so that whatever any external frequency disturbance are there, that will be neutralized. So that kind of provision you should have. That is called low electromagnetic interference. And making for all these things, you are not supposed to increase the cost. The cost of production should be very, very low. If we are able to satisfy all these points, definitely people will come forward towards the electric vehicle. No doubt in that. Right? Fine. Now, let's go 3 parts which I told you, right? What are 3 parts which I told you? One is the motor, and the second thing is battery, and the third controller, right? We'll see one by one. First thing what I told you, motor. That is a very important. Without knowing the electrical machines motor, you can't crack anything in electric vehicle design and all, right? So there are many things are there. Even any industry if you are going, definitely you should know this kind of knowledge. Otherwise, you know, the Bose company and Tata Elxsi, there are many people nowadays providing intensive for the students. You cannot apply even. You know, these 3 things you should be familiar. Electrical machines and controller, the drives, power electronics and the battery. These things are essential, right? And the first thing is, in motor, there are many types of motor. May I know what are the types of motor popular? Popularly you studied, you tell me, then I can tell you which will be suited here. Induction motor, then synchronous motor, then DC motor, then okay, fine, no problem. This much only you know. Other motors you have not studied, like a SRM, switch reluctance motor, not studied. Not studied, really not studied. Okay, fine, no problem. Okay, sir, no issue, sir. Just I asked, sir. Okay, so now let's go DC motor. In a DC motor, what are the types of DC motor? Shunt motor, series, compound. In compound, there are types are there, na? Long shunt, short shunt, then differential and cumulative. According to the operation, according to the connection, compound can be further classified into 2, right? Fine. But shunt is series. Series motor we can't use here. The one of the major advantage, some limitation. What we used to call DC series motor? High starting torque. Excellent torque we will get. That is why up to now, there is no motor replaceable for the DC series motor for electric train. Whatever the electric train in the entire country which is running because of DC series motor. Now the DC series motor is bit replaced with the 3-phase slip ring induction motor. But DC series motor is one of the best motor in a lift everywhere because higher starting torque. Fine. But that kind of torque is not required whereas in electric vehicle. So electric vehicle we can't use DC series motor. Other motor is what? DC. Shunt motor. What is the major drawback of DC shunt motor? Speed? And boldly you can say, na? Speed is constant, which means constant speed motor we used to call. Why? Flux is constant. I don't want to go in operation. Why flux is constant? Why starting that I don't want to go in detail. You can study. But you need to understand DC shunt motor is almost a constant speed motor. For example, 1500 RPM is a rated RPM. I cannot control. I can control till 1200. 1200 to 1500 I can control. But when I am trying to reduce the speed by acceleration less than 1200, suddenly it will go to 200. Between 200 and 1200 you cannot control. So do you want the DC motor in case of electric vehicle? No, it is not needed, right? But still we can use. That is called PMDC, permanent magnet DC motor. So that is one of the popular motor. No need of any brushes. Directly I can provide a DC supply. Instead of the electromagnet, permanent magnet would be there. So PMDC motor up to now popularly we are using where all E-2-wheeler, E-bicycle and all I think most of them are here, right? Electric bicycle and the E-scooter with a low rating. DC shunt motor with a PMDC concept we are using. Another motor is a popular motor everybody aware about. I think here BLDC motor. What is a BLDC motor? Brushless DC motor. Okay. Another motor somebody told in AC other than induction. Somebody told synchronous motor. What is the drawback of the synchronous motor? Self-starting, okay. Self-starting is not there. Another drawback. Constant speed or the name slightly different. It will run only in a synchronous speed. Of course, constant speed we can tell, but I am going to replace that word. Synchronous motor, asynchronous motor, there are two types are there, right? Asynchronous motor, what is it asynchronous motor? Induction motor is basically known as asynchronous motor. See, there are two types are there. Without knowing this, you can't crack. Again, I am telling. There are two things. Synchronous, asynchronous. Synchronous motor will run only in a synchronous speed. Asynchronous motor will run other than the synchronous speed only. But it never runs synchronous speed. For example, 4-pole machine 50 Hz. N is equal to 120 F upon P. So let it be 1500 RPM. So my synchronous motor will run only 1500 RPM. But whereas asynchronous motor, other than 1500 RPM, it will be running till 1499 or 1501 to top speed. But it never runs 1500. That is why they are calling asynchronous, synchronous. Okay. Now, sir, one speed only running, no, it is a constant speed only, no. But how can we use in an electric vehicle? We can use only one speed. Whatever you raise acceleration, vehicle will run only one speed. Do you want that motor? We can't use, but still we can use. Anybody can comment? Okay, before that, I will tell you what is called self-starting. May you know what is called self-starting? Synchronous motor having a self-starting capability or not? No. Why? Pardon? Because of? So? Okay, reason. I understood. Partial answer is there. I appreciate. Because of RMF? Fine. Any other exact answer? Anybody? Pardon? Absence or no, presence of RMF is the bigger problem. Okay. Yeah, I'll explain you. See, for example, you need to understand first of all what is called RMF, rotating magnetic field. There are two main portions are there. One is the armature winding, stator. Another one is the rotor. Rotor having basically electromagnet. If it is electromagnet, that is a synchronous motor. Instead of electromagnet, when you are placing a permanent magnet synchronous motor, PMSM. These two popularly using, especially PMSM, most of the electric car, it is going to be implemented. PMSM, e-truck and all there, no, they are going to implement only PMSM. But you need to understand PMSM, major drawback is called self-starting. If you know about the self-starting, easily, how can I use for the electric vehicle, easily you can understand. First I will tell you what is called self-starting. Before that you need to know what is called rotating magnetic field. Armature winding would be there and inside permanent magnet would be. You just assume permanent magnet is a rotor rotating and the armature winding will be the stationary portion, right? Three-phase winding everybody know. Single-phase winding means phase and neutral. Three-phase means R, Y, B. What is the time difference between the R and Y phase? There is a phase difference, time difference. For example, if 50 Hz frequency, one full wave, what is the time period? 1 by 50. What is the time period? 20 millisecond. 1 by 50 is 20 millisecond. Nah? So T equal to 1 by F. So one full cycle, 20 millisecond. Am I right? So what is the phase difference between R to Y, Y to B and B to R? 120, 120, 120. Am I right? So one full cycle, what is the phase angle? Phase angle, full cycle, 360 degree. If it is a 120, so 360 divided by 3. Am I right? So what is the time period? 20 millisecond. So 20 millisecond divided by 3, how much coming? 6.67. So which means R phase is there after 120 degree, or in terms of after 6.67 millisecond, Y phase will come. After 6.67, again B phase will come. What does it mean? R phase, Y phase, B phase. Every gap 6.67 millisecond, R phase will get flux, Y phase will get flux, B phase. Now what I will do, in the stator, R phase I will keep here, Y phase I will keep here, B phase I will keep here. What will happen? At instant, R phase will get flux. So here flux. Flux means when current is going with any conductor, flux would be there around that conductor. So here group of coil, more number of flux. After 6.67 second, here Y phase will get flux. After 6.67 second, B phase will get, right? Again R, Y, B. So R, Y, B, when I am placing, here flux, after 6 point, here flux, after 6.7, here flux. Now what will happen? Again R, Y, looking like a magnetic field is keeps on moving. I think you might have seen most of the God photos and all, no, LED will be fully rotating. But basically LED will not rotate. Certain LED will run certain time with the help of 555 timer, T formula is there, na? The gap, different frequency. Here LED will run, then here. But for looking, LED keeps on rotating. Light. But originally that is not moving. But for our impression, it looks like moving. The same thing, flux are getting energized. But for our understanding, it's a magnetic field keeps on moving. That change in magnitude is there, na? That is depends on frequency. That is what? Ns equal to 120 F upon P. If it is a 4-pole machine 50 Hz, 1500 RPM the flux will be moving. That is not moving. Energization is happening alternatively, right? So now this is called rotating magnetic field. Now, the synchronous motor is running because of force of attraction. There are two principles. Force of attraction, force of interaction. Right? Induction motor will run force of interaction. DC shunt motor, DC series motor, DC compound motor, slip ring induction motor, everything will run because of force of interaction. But only synchronous motor run because of force of attraction. Stepper motor also force of attraction. Force of attraction mean what? Two poles are getting attracted, opposite poles. Now, here R phase is there. Now I am having a magnet, permanent magnet, south pole. So south and magnet energized, both will be attracted. Next 6.67 millisecond, Y phase will get flux, right? So this magnet move towards Y phase. Next 6.6 second B phase energize. Here it will move, which means because of my alternate energization, what will happen? This magnet attracted, like that. Because of this speed, my rotor also will follow. You got it? This is called magnetic locking. What is called magnetic locking? The magnets of stator pole, rotor pole attracted together keeps on running. Right? Now I given a 58 supply. 1500 RPM, very fast it is evolving, right? Now rotor is 0 position. Very fast. I'm not able to catch. When I'm trying to catch, within a fraction it will go. But I'm not able to move or sudden change. For example, in electric normal train which is running at very fast, around 50 km per hour it is running. You are standing in a platform. Do you think will you able to catch the train by standing? Why? It's a very fast. You are not able to catch. But what you will do if you want to catch the train? You have to run same axis. So when you keeps on running towards the speed 40 km, your speed at least 30 to 40 km per hour, then immediately you can jump. Like that, synchronous motor, stator is running very fast. Rotor not able to catch the stator. Right? What you have to do? You just run in hand. So what will happen? Rotor also will run. Suddenly it will pick up, then it will run. So some force is required to start the motor. That is why synchronous motor not having a self-starting. That we have to provide with the damper winding, other things and all. That we don't want. Now, in case of electric vehicle, if I want to adopt, how can I achieve self-starting? Moment I turned on, engine has to start, motor has to pick up. When I'm raising acceleration, speed has to run. Right? So what I supposed to do for that? Instead of that, I can, there are two things. If you want to catch the train is running 50 km per hour, either you have to run along with the train axis. Your speed should be near to the train speed, or reduce the train speed to 1 km per hour. Reduce that. Easily you can catch, na? So like that, rotating magnetic field speed is there, na? Ns equal to 120 F upon P. Reduce the frequency. What will happen? Only 1 hertz only. So which means 1 into 120, so only 120 RPM only. So 120 divided by 4 may again 30 RPM only. So speed of the stator will be very, very less. So rather than increasing the frequency 50 Hz, reduce the frequency to 0.5. Very less speed. Now rotor easily can able to attract. Then gradually raise the acceleration. What will happen? Your frequency gradually increasing. So that rotor also able to attract. You got it? So rather than giving a 50 Hz at time of starting, give a frequency. Reduce the frequency. Reduce the speed of the rotating magnetic field. Easily it can able to attract. So now you understood synchronous motor also can be utilized in electric vehicle but not traditional way. What we have to do? We have to reduce the frequency. You got it? So when acceleration, when I am pressing the acceleration, what is happening? Frequency. So when I am increasing, decreasing, what's supposed to happen? Frequency has to be either increased or decreased. So which means by touching the frequency, by controlling the frequency, you can control the speed of synchronous motor. So now hereafter somebody is asking, don't say synchronous motor constant speed. No, I'm changing the speed. So synchronous motor is not running constant speed, but alternate way you can say synchronous motor run only in synchronous speed. But I'm reducing synchronous speed itself. Of course, rotor speed also will reduce. Rotor speed N is equal to NR. Why? Magnetic locking, attraction. So as long as the force is appears, my motor will run. I should not leave the force. That is called loss of synchronism. Once synchronism losses, then attraction will not be there. So I have to maintain the attraction. So which means gradually I have to increase or decrease the frequency. Got it? So PMSM, most popularly we are using. Same thing, induction motor. When I am raising the acceleration, leaving the acceleration, what will happen? When I am raising the acceleration, frequency will increase. Leaving the acceleration, frequency will get reduced. Induction motor also same. But as I told you, it's not force of attraction, force of interaction. 1500 RPM this is running, it will be 1450. If your synchronous speed itself reduced to 200, your rotor speed is 150. If synchronous speed itself 50 Hz by reducing the frequency, 40 RPM. So by increasing the frequency of stator, again you can control the rotor speed. But running because of force of interaction, that is running because of force of attraction. Only small speed difference would be there. That is why two motors are powerful motors. One is the PMSM, another one is the synchronous motor, PMSM and three-phase induction motor. These two are most popular motor. Up to now, we are using most of the industry, Bose, Tata Elxsi, and Hitachi and all nowadays started actually. Many companies, often they used to come NIT Calicut for the placement. Everybody get recruited towards the electrical department. Many people nowadays, more than 70% people are moving towards electric vehicle technology only. Most of the companies are attracting because they are going to invest in huge. There are more than, around 2 to 3 crore vehicle has to be replaced with electric vehicle very soon. There is no option. Huge investment is required. Huge manpower potential is required. But everybody should understand about this technology. Without that, you cannot grab in that sector. Right? The future is full and full electric vehicle only. Right? Fine. So, there are popular motors as I told you, whatever. DC motor, permanent magnet DC motor, PMSM, three-phase induction motor, and SRM we are using, but costlier. We are not using that much costlier motor, that one, because number of poles, design and all difficult. Another one motor is a popular at present scenario is called BLDC. There is no difference between the PMSM, BLDC. Both are same. For example, PMSM is there. Now I am having one inverter. Inverter, what is the job of inverter? Which convert? AC into DC is controlled rectifier. DC into AC means inverter. So inverter, when I am giving a DC supply, what is the job of inverter? Which convert DC into AC. That AC where we will apply PMSM motor. So inverter, PMSM, both the combination, this is known as BLDC motor. Why? There is no brush. Rotor is permanent magnet made up of. There is no brushes are required, right? So brushes are not there. And AC supply you are giving, but input is what? DC. Why? Inverter will convert DC into AC. So I given a DC supply, there is no brush. So that is why brushless DC motor. Without inverter, directly when you are giving AC supply, that is called PMSM. If somebody is asking in interview, what is the difference between the PMSM and BLDC? There is no constructional difference in a motor. Motor remains in PMSM. If I am giving a AC supply, PMSM. Same motor with the help of inverter, I am converting DC into AC. That whole combination becomes BLDC. Most of the Chinese-based vehicle, they are launched in the e-tricycle, e-scooter, even the ampere vehicle, whichever running, whenever you are seeing in a vehicle, now market, roadside, full and full BLDC motor only. Only inverter would be there, PMSM would be there. That's it. But inverter is not a sine wave, it becomes a trapezoidal. That's all the difference. Trapezoidal nature will be applied inside the motor, then that is called BLDC. Replace the inverter, trapezoidal, nothing. Directly give three-phase supply. Then PMSM. Right? That PMSM only popularly we are using wind energy conversion system. All the wind turbines are available. In India, 54 gigawatt we are generating. Full and full PMSG only we are using. So these are the popular motor. Permanent magnet DC motor, BLDC motor, PMSM, three-phase induction motor. Much popularly we are using. Everybody should be aware about these electrical machines. Very, very important one, right? And there are two types of BLDC motors are coming in the market. One is a BLDC outrunner, another one is a BLDC inrunner. Outrunner you can see wheel would be there and a separate gear mechanism, the belt drive or something. So you can adjust the speed ratio. But one of the major drawback is because of that almost 10% losses will go. Mechanical, no. 90% only you will get. But whereas the inrunner not like that. Wheel would be there, inside motor itself like that mounted. So when giving a supply, motor will run, wheel also, there is no any mechanical conversion. Right? That is what most of the e-scooter and all we are following. All the electric vehicle two-wheeler, we are having BLDC inrunner type. Only directly cable is there. AC supply, trapezoidal will come. From where it will come? With the help of my inverter. Inverter where it is? Which is mounted in the somewhere in the e-wheeler, two-wheeler itself. Which convert DC supply into AC. DC from where I am getting? From battery. That's all. DC supply from the battery, inverter and this motor. That's all. Nothing is there in electric vehicle. Very simpler procedure. Only you need to understand how the controller will act. What are the mechanism inside? If that you understood, then job over. Nothing to learn about the electric vehicle. But you need to understand the motor dynamics of the vehicle. That is a very electrical machine you should be strong, and power converter you should be strong, and the battery. These three knowledge if you are having, you have a bright future, I am telling you. No doubt in that. And other popular motor is the induction motor. Induction motor is a constant speed by adjusting the voltage. That is why, as I told you, don't adjust the voltage in a traditional way. You have to control the frequency. When you are adjusting the frequency, let's control synchronous speed itself. Then automatically my rotor speed also will control. So somebody is asking in an interview somewhere in electric vehicle, how to control the speed of the motor. Don't say simply by adjusting the armature voltage or something like. No. We are going to control the frequency. Frequency when you are controlling, automatically speed of the motor will control, so that easily I can achieve the electric vehicle controllable speed. Got it? Fine. PMSM, this is a popular company that we are having a PMSM. As I told you, there is no difference. Anyhow, I am going to provide the entire slide to you. Don't worry. In the clear understanding would be there. You can just go through, you will get a very good knowledge about this one. PMSM is a trapezoidal nature, and three-phase supply directly when you giving, that is a PMSM. That and all there. Okay. This is SRM, no need to discuss. And like this. Very, very important thing is to know what it is there inside vehicle. Na? Wheel would be there, and the motor drives, and the converter. That box is there, na, black wala. That is the converter. Sometimes it will be inverter, sometimes DC is converter. It depends on the motor. If it is a PMDC motor, converter, normal converter. If it is a PMSM or maybe what is called BLDC, inverter would be there. We have to control. Regenerative braking also can be obtained over there. And one motor. That's all. There is no any gear mechanism. First gear, second gear, third, nothing is there. Just to increase the accelerator. What is happening? Frequency will increase. Leave the acceleration. Frequency get reduced. So which means by adjusting the frequency, I can control the speed of the motor very minute way. Right? So now, in case of engine vehicle, normal in car and all, what would be there? Front, back side is there, nothing would be there, we can keep a luggages. What about front? Engine, na? Everywhere engine is there, petrol engine, a diesel engine, and the compressor, AC, entire thing would be there. Now you just imagine, in case of electric vehicle, as I told you, this motor is mandatory, then this converter is mandatory, then battery is mandatory, we can keep a bottom, entire bottom, because mechanically it will be balanced. When you are keeping only back side, heavy weight would be there. So what we will do, other than the wheel, no, the entire portion will be distributed like this, batteries, right? So battery will be entire bottom for the mechanically balanced, on the back side motor would be there, inverter very smaller portion. What I can keep at front? Engine is there, na, right now in car. What would be there? Nothing would be there. So we have two places to keep a luggage. It will be like this. Full and full empty. Tesla car, Model S, it is going to come in the market. 2025 they are going to launch. They are going to provide less than 10 lakhs. Right now whatever available in the market, around 15 lakhs minimum. With regenerative braking, it will be around 18 lakhs. They are going to hit the market within less than 10 lakhs. So all the engine vehicle will be replaced. Two places you will get to carry the luggages. Front nothing would be there, back nothing would be there. Battery will be bottom. One small converter, one motor, that's all. That is why it is going to pick up like anything. Right? So we have a huge space. That too induction motor, variable voltage, variable frequency. By only adjust, no need of whatever in an engine vehicle, there are three. ABC we used to call. What is called ABC? Acceleration, brake, then clutch. What is the purpose of clutch? Gear change. I told you there is no gear. Then remove the clutch. Then what is that? A and B. Acceleration and brake. So now I don't need to apply every time brake. Why? I want to reduce the speed. What I have to do? Raise the acceleration. Frequency increase. Leave the acceleration. Frequency decreases. Frequency decreases. What about my motor speed? So then no need brake. Only emergency brake. So only one acceleration, single pedal, only rise, reduce the speed, rise, reduce the speed. When I am reducing the speed, regenerative braking also will take place. So only acceleration, that's all. motor will be controlled. No need anything, that clutch or nothing. Entire set is not at all required. You got it my point? This is the way we are going to operate. We are operating. Tesla, they have done excellent way. Other Bose vehicle, but it is a costlier. Right now, what is available in the market actually. The summary of motor selection, I told you in a DC, na, PMDC. E-bicycle would be there, right? And the two-wheeler would be there. For this and all, PMDC, BLDC is popular, right? In case of e-tricycle, e-rickshaw, so for that also BLDC is popular. Then e-car, electric car, so induction motor, PMSM is popular. If a heavy duty vehicle, like a e-truck, this kind of vehicle and all, SRM is best one. So there are three categories, LDV, MDV, HDV. LDV means light duty vehicle, MDV means medium duty vehicle, HD means heavy duty vehicle. Right? Heavy duty, light duty, medium duty vehicle. So everywhere, everything is available. For example, DC motor, PMDC, of course we are using. Somebody is asking, electric motor, which motor are you, sorry, electric vehicle, which motor are you using? You should not say only one motor name. Everything we are using. PMDC, we are using. PMSM, we are using. Induction motor, we are using. BLDC, we are using. SRM, depends on the type, depends on the variety. You are not supposed to say only one motor, this is popular. No. Electric car, which motor somebody is asking, you can say. Either induction motor or PMSM. Two-wheeler, which motor? You can say boldly BLDC motor or PMDC. E-bicycle, PMDC is best. E-scooter, BLDC is best. Like that you have to classify. That is what based on the rating. Less than 4 kilowatt, more than 4 kilowatt, like that they have classified. Every motor we are using. Don't stick with a single motor. You got it? Fine. Now, let's go losses. Compare, I already told you the performance is the best, no doubt in that. And as I told you, rupees, 5 rupees that you have to spend per kilometer. If I want to travel 200 kilometers, how much you have to spend for petrol, diesel? 1000 rupees. Why? Per kilometer, 5 rupees. 200 into 5,000. But whereas in case of 200 kilometers in my electric vehicle, less than 50 rupees, 40 rupees. Why? Only 10 paisa, 20 paisa, not at all more than that. Per kilometer. It's an excellent one. Right? Fine. Now, the question is, what about the losses? May I know what is the losses in engine? Anybody can? Overall percentage of losses in engine. Okay, what is the efficiency in other way I can say? Efficiency out of 100%, how much percentage of efficiency I can tap in engine vehicle? Huh? 50. Only 50. A percent, somebody can say some random number, but based on your understanding. 40 to 50. So overall efficiency is 40 to 50, which means 60% of the energy is being lost. Loss is in the form of heat. Radiator, that is all to make them cool, that is fine. So now one thing you can understand, efficiency is very, very low, but I will tell you what is the actual efficiency. Before that, 3 conversions are required. Aerodynamic force, electric vehicle design, engineer will be allotted to you. 3 forces are mandatory. Aerodynamic force, rolling resistance force, another one is a braking. Aerodynamic mean very, very simple. Against the air movement, your vehicle has to move. Wind velocity is coming this way. Your vehicle is moving. Against the wind velocity, your vehicle has to move, right? So extra force is required. Opposite direction when your vehicle is moving, wind is supporting to you, right? So now less force is required. So that is called aerodynamic force against air, right? Second thing, rolling resistance. When wheel is moving, whenever it is jumping like this, what will happen? Some frictional would be there between the ground and your tire, right? Against that friction, you have to make a rotation. If it is a pakka plane, easily you can move. Then road is not that much. Then you need a more friction force is required. That is called frictional force. Technically, it will come. Engineer perspective, there are 3 forces. One is against the air movement. Another is a rolling resistance force. Everything there is a calculation. Force required for a rolling resistance, force required against aerodynamic drag. Other force is basically gravitational force, or maybe we used to call like a braking. So 3 way the force is basically classified. I will tell you what is the distribution. You can understand. First thing, out of 100% in fuel tank, right? City driving, you know very well, urban area. Every time often you apply the brake and all, right? Standby also sometimes would be their engine because of your traffic. then again movement. So losses, if you are looking, it will be like this. 76% engine losses, not efficiency, loss. What will be the remaining I am getting? 76 gone mean remaining, how much could be? 24 only. But out of 24, I am having a standby also 8%. Standby mean what? Even vehicle is not moving, still 8% of petrol consumption will be taken. Why? Standby mode. You know what is called standby mode, right? So 8% is standby mode, 76. How much I will get net? 16. You see, somebody is asking, what is the efficiency of the engine vehicle? 16%. You have to ask next question what? Sir, when I am driving a highways or normal way? Highway mean your efficiency is not this much because standby mode is not that much. So city driving, definitely standby mode loss is there. So which means somebody is asking what is the efficiency of the engine vehicle? You have to say 16%, 1/6 only. So out of 1/6, that is a drive line, right? Now again, gear is there. First gear, second gear, third gear. There also some drop is there, right? If somebody knows smooth transition, they will get better way. Some worst driver, they know how to change the gear, then again more losses. But on an average, our losses in drive line, again we are having a 3% during that drive. So finally, how much I am getting? 13%. 13% only which I am applying to my wheel. There are three forces I told you. What are the forces? Aerodynamic forces, rolling resistance force, brake. When often you are applying the brake, again some losses will go. Right? But finally, you see how much I am getting. 13% I can able to apply, in which from the research perspective, 6 for brake, rolling resistance, again the tire movement, 4%, against air you need a 3%. So which means 1-3% only will be hitting into my vehicle. It's in city. But in case of highway, I agree, there is no standby, little bit extra would be there, right? But heat of the engine will be more, highways. So 77%. So 77% there is no standby, 23% I will get, drive losses will be 4% would be there, often used to change the gear. But in case of city, no need, only second gear, third gear only you will drive. So finally, 19% you will get. So somebody is asking what is the efficiency finally you are going to hit in the vehicle. In case of engine, you have to say in a city side 16%, in a highway side 19%, which means overall maximum 20 only. You never expect beyond that, right? Okay, now I'll ask, what about my electric vehicle? How much it could be? Anybody can say? How much it could be electric vehicle? There are three things only I told you. You have to keep it in mind. In here I told you engine would be there, then gear would be there, then we have a tire and other thing. Now, in case of electric vehicle, what are the three major portions? First portion is what here? Motor. Next, battery. Okay, that is separate. Out of the battery only we have to consider. Second, another thing is what? Controller or converter plus controller you can say, or maybe drives better, right? Okay, you tell me now, what is the efficiency of motor? I think everybody performed in the laboratory, always plotting the graph like this, like a hills, right? What is efficiency? Whatever you are running in your lab is an old motor, 30 years old they purchased. Don't compare with that motor. In electric motor having a good efficiency, but don't think so 99% in that. Transformer only can give 98, 98. Because it's a rotary, movement is there. What is the efficiency I can expect? 70 and all means no, that you have to scrap actually, there is scrap motor only. Efficiency 94, 93 and all we will get. On an average we will consider 90%. So motor efficiency is where it is sir? It's a hybrid system, sorry. Hybrid mean it's outdated, that is why I am not explaining. Earlier case it was there, engine, motor both. Right now battery came into picture, lithium came into market. So no need hybrid. They have destroyed the hybrid. Only BEV, battery operated vehicle. Okay, let's see. Motor, what is the percentage as I told you? 10%. 10% mean finally how much I am getting? 90%. But drive also having a certain losses, right? Because here power converter, IGBT, MOSFET, Everything is there. You know very well there are two major losses in the device also. Switching loss, conduction loss. There also some losses are there. 60% of the over losses will be taken only switching loss. Right? So 14% will be the losses. So finally how much I am getting? Other than that. But their losses how much in engine? 76%. But here, 76% I am able to tap. It's one of the excellent behavior. Right? So that is why, as I told you, the cost per kilometer, why is it getting reduced? There is no mechanical movement. Engine, you know very well, combustion, you know, right, 2-stroke, 4-stroke and all, like a linear movement. That has to be converted into rotary movement. With the cam, again, it has to be distributed. Everywhere mechanical. I told you, more than 10,000 spare parts are moving, even small screw. But here, nothing is there. Only differential directly we are connecting with the wheel. Right? So now, 76%, now easily you can distribute 3 forces. Aerodynamic force, rolling resistance force, brake energy. 3 forces. You can see the classification how much it could be. Approximately 29% you can use and 35%, 11% it can be distributed. So 76% you can tap. One of the best thing. Okay? This is electric vehicle. Now, the other thing, sir, you are talking about this much efficiency, very cheap and best. Why government is, tomorrow itself they have to announce, none of the traditional vehicle will be allowed to run in a country because of the pollution and very lower efficiency. It should be very higher efficiency in the electric vehicle. Let's replace. Tomorrow they let them apply a policy. Like how the 2,000 rupees road they banned. Let's ban that traditional vehicle. Let's buy electric vehicle. Why they are not doing? It's the best thing, na? Am I right? But why they are not doing? Something is there. Something is there. What is that something? Economy is fine. Of course, technology we don't have up to now. That much we have not. Sir, please, when break time is coming, let me know, sir. I will forget myself. So, what is the situation? Something is there. What is that something? Battery. Okay, battery is one of the drawback they are telling. I accept. Because there are many types of battery. May you know what are the types of battery? You might have heard. No need to study. Lead acid battery, lithium battery, lithium polymer, lithium, everything lithium only. Then nickel cadmium. Then redox, okay, leave it. There are many batteries are there, right? Lithium is the best one. Reason, power with respect to weight. Less weight, more power. If more weight is there, that itself takes more weight. I cannot use my payload. Only one passenger only can ride. I don't want. Lithium is less weight. Light weight, more energy. That is called kWh upon weight, kg. kWh upon kg means lesser weight, more energy. 1 liter petrol, when you are having less weight, but energy will be very huge, right? But same kind of battery, you should have that caliber. Lithium having that is called rare earth material we used to call. Rare earth material is very important, but we don't have that. Thermal power plant, you know very well, 70%, 63% as on 2023 June, 63% we are depending on only thermal power plant. But thermal power plant, what is the major source? Coal. Do we have a coal? No. That pure brown coal is required, having a very good caliber. But that kind of coal we don't have. What we are doing actually, we are purchasing from Russia. Everything we are importing. Money, whatever the economy, whatever the power generation, whatever you are paying the electricity bill, indirectly going to Russia. Right? Same thing, lithium, we don't have. Who is having? Some other Middle East countries they are having. These Chinese people, they have taken the entire thing by giving a loan, they are unable to repay, they have taken the entire resources. They captured. Now, last 2 to 3 years, what we are depending only for crude oil. From the crude oil only we are getting petrol, diesel, everything. You are applying 100 rupees diesel or petrol, the money which is indirectly helping to develop the other nation, Middle East nations, right? All Arabian nations. That is why 1 dinar and all, 234 rupees, which means 234 times they are richer than us. US dollar is 80 rupees, which means 80 times they are richer than us. 1,000 rupees they are earning there, but which is equal to more than 80,000 rupees. That is why everybody is working over there. If 1 rupee equal to $1, 1 rupee equal to 1 dinar, now nobody will go to other nations, right? So that difference, why they are making? natural resources they are having. Full and full desert. 200 years and all we are looking, no. In India is one of the powerful one. I think Silk Route and all you might have seen. Everywhere we supplied. The economy, we are the top actually. Everybody trying to know where is the India. Because we are having entire requirement what human is required. But the day passes, year passes, what happened actually? They identify the rare earth material under the desert. They understood the minerals are available, crude oil. So that is why they have ruled the entire world 234 times they are powerful than any other nation. In India, compared to 230, that is why Dubai are developing like anything. They don't have any research potential. They don't have any R&D department. They don't have any huge technically sound manpower. No, everybody in it. But only what they are having. By God gift under the earth, they have a resource. So which means rare earth material who are all having, they can rule the world. These people understood clearly, these Chinese, they grabbed wherever lithium sources they reserved actually. Now, more than 80% of the lithium, you know where it is coming? From China. If tomorrow I am trying to replace the entire nation with an electric vehicle, then everybody has to go and hand the entire money to China. Next, how last 20 to 30 years, the Dubai country, if you are looking, no, just to take an example, Dubai only, but other nations also, take a Dubai, 30 years before, how it was. Go and see today, how it was, how it is. Why it is happening? Because of our money, our economy, indirectly helping them to, we are not forcing, but we are going down. So same situation should not happen to develop the China also like that. So that is why government slowly they are adopting the policy. I don't want to replace the entire thing. They have developed, let it be. If today when they are announcing, entire thing will be coming only from China only. Because their lithium resources they kept full and full. If entire nation can be supplied. So now they are trying to identify where this kind of rare earth material like lithium resources are available in entire India. They identify nearly Jammu Kashmir. More than 16,000 tons they have identified in India. So that is the one of the best thing ever seen, Jammu Kashmir, that we identified lithium resources. Now plant and all we have to do, but Chinese already they have deployed. So now I think you can understand, because of rare earth material resources, our country is not pushing at massive changes in electric vehicle sector. Gradually only. This is not only one thing. Another one problem also there. This is the first thing. Second problem, when we are trying to charge the electric vehicle, from where you will charge? In your home only you will charge. In your house, during the night time you will charge. That is what, once you purchase, what time you will charge? Whole night you will charge, and morning you will drive. Whole night, from where you are consuming energy? From the grid. From the grid means the generating station has already told you, 63% depends on this one. Again, everybody started using electric vehicle. 30% extra will come. Those 30% suddenly where I can contribute? I have to establish 2 or 3 more thermal power plant in every state. Then for that to run that power plant, what is required? Coal. From coal, where I have to? Again other country, which means indirectly again I am going to depend on another country. If the situation happens, again our economy goes down. Our country money should not go outside. Other country money should come inside. That is the policy. Right? So what government will do? I don't want all of a sudden to do. Unless until very good infrastructure. 2 things are required. One is electricity. Another one is the rare earth resource material. These 2 things, if it is there in our country, then I will change that day. One sudden I can do. That is the government policy, why they have not adopted. Gradually they are doing. Electricity, of course, we are having a solution only with the help of renewable. In the renewable, there are 2 things popular. Solar and wind. Wind identify potential only not more than 60 gigawatt. Already we tapped 54 gigawatt. We have tapped. Everywhere identified, done. But solar, more than 600 gigawatt. You know what is our Indian generation? Anybody knows? No, 700 not. That much is excellent. 450 is our requirement, demand. 420 gigawatt is the installed capacity. But US, they crossed already 1200. Right? But we are having 420 as on June 2023 data I am talking actually. Ministry of Power, you can search also. 421 gigawatt is our installed capacity. Very, very important. Again, I am repeating the word installed capacity. Installed capacity doesn't mean that you are generating. Wind, throughout the year 365 you won't get. Only particular months. Hydropower plant, do you have water in every dam 365 days? No. Summer you won't see empty. Only rainy season. So, which means the average generation only 250 gigawatt only. So now what government has to do for the electricity? I have to one side increase the solar power plant. Other side, I have to look only the rare earth material like lithium or any other resources so that I can adapt. These two things 100% satisfied, then they will change like anything. But still, we are doing it gradually. That is what 10-year plan. Right? So you got it now. So now, at present scenario, as I told you, what is the efficiency of the engine? 16% finally I am achieving. What is in case of this one? 76%. Now, overall efficiency. Overall mean from the earth metal to from the wheel. What is the efficiency? That we have to see. You got my point? Earth metal to wheel. For example, this slide. Well to wheel we used to call. Well to wheel efficiency. One of the interesting thing. You can see there are two things. From traditional way, I am taking a minerals, right? Engine, whatever the petrol or crude oil, whatever I am exporting, finally with the petrol pump I am applying the car, right? This is a traditional. This is with the electrical. From electrical mean, again from the rare earth material, either coal or whatever minerals, with the help of power plant, either gas power plant, diesel power plant, or thermal power plant, or nuclear power, whatever it is, finally the material from earth only, right? So from well only I am again taking. So from here I am generating electricity. From that transmitting. From that I am having a charging station. From that charging station your house, whatever it is. Then you are going to charge, right? Now, here having some drop losses. Here having some losses while transmitting. Here also having some drop, right? And finally we will applying some inside losses. That we have seen, right? In case of what is called electric vehicle. What about these losses? Definitely something would be there. Whatever the transmission losses, something would be there. Then finally, this is 76%, excellent, right? You can see in terms of number you see. 33% is the overall efficiency. 94%, that is unaccounted loss we are not talking. Originally 14% is the losses, but 6 to 7 only other nations and all, that only we have taken. Finally, 31% I am getting. You see, 33 here, 77 here losses, here also 6% losses, finally 31. But 31% I am applying, but finally wheel how much I am tapping? 76. 76% of 31 how much? 23%. You see, well to wheel, 23 only I am getting. Don't think so, 76% I am getting. No. Who will be taking care of all these things? You got it? What about the engine-based vehicle? What about the transmission loss? You won't get that much. Maybe little bit would be 1 or 2%. Here, of course, during refining, there are certain losses. You see, percentage, 82, 98, 80% I am getting. 80% I am able to reach here. Out of 80, wheel to here, wheel. Again, 16% only, right? 16 into 80, 80% of 16, how much? 13%. You see, 13%, 23. There is no much difference. It's not that much huge. You got it? Why? There are several mediums are there. Still this is conventional. I want natural resources. That money is going to other nation. I don't want it. You got it? So that is why policy slowly they are adapting. Because many of them are keeps on asking students, sir, last 10 years people are talking about why I am not able to see anything in electric vehicle in the market. Literacy people, uneducated people also asking, my parents are asking, I am not able to explain to them properly what is happening. The entire story we need to say. Got it? Fine. Huh? Yes, sir, please, sir. We'll go for a 10 minutes break. Okay, then we'll start. We'll resume the call.